Good morning, students. Chapter 7, System of Particles and Rotational Motion. In last lecture, we have discussed about what is center of mass. Then, center of mass for system of particles in one dimension and then two dimension. Now, today we will see motion of center of mass and Newton's second law of motion. Newton's second law of motion. Okay, again, if I have particles x, y and it is z, that it is origin. We have particles mass m1, mass m2, suppose it is mass m3 having position vectors r1, r2 and r3. Okay, then the center of mass, for example, it is here, it is center of mass, then its position vector is, it is r, center of mass. Now if these objects, these particles m1, m2 and m3, they are in motion, they are in motion. They suppose these particles having masses m1, m2, m3 dash dash dash, they are moving, they are changing their position. So yes, what is change in position for center of mass? We know that change in position with respect to time, it is called velocity. So if this particle m1 is moving with some velocity v1, this particle m2 is moving with some velocity v2, this particle m3 is moving with some velocity v3, then what is velocity of center of mass? Okay, that's why this theory is named motion of center of mass. Okay, yes. In last lecture we have obtained one equation that is okay, m r center of mass is equal to, it is m1 r1 plus m2 r2 plus m3 r3 plus s2 plus so on mn. Okay, it is one equation that we have derived in last lecture, in last theory. Now if mass of particles does not change with time, mass of particle does not change with time. Suppose mass of particles does not change with time. Okay, but their position continuously changes. Then if we differentiate this equation with respect to time. If we differentiate this equation with respect to time, that is d upon dt of m r center of mass is equal to d upon dt of m r plus d upon dt of m2 r plus so on d upon dt of mn r. Okay, now mass of particles do not change with time. So yes, how to write this equation? Yes, I can write this equation as m d upon dt of r center of mass is equal to, here it is m1 d r1 upon d plus m2 d r2 upon d plus s2 plus so on mn d rn upon d. Clear about this equation? Okay, yes, it's simple. Okay, how to write this equation? Okay, now, yes, now we know that differentiation of position vector with respect to time, it gives velocity. Yes, it gives velocity. So yes, I can write this equation as it is m v center of mass. Why v center of mass? R center of mass, it is position of center of mass. RCM is position of center of mass. So differentiation of this position with respect to time, it will give velocity of center of mass is equal to this side m1 dr1 upon dt. rate of change of position of first particle. So it is velocity of first particle. dr2 upon dt, rate of change of position of second particle. So it is velocity of second particle. drn upon dt, rate of change of position of nth particle. So it is velocity of nth particle. So now, if we differentiate this equation, how to write this? mv center of mass is equal to, it is m1 v1 plus m2 v2 plus raised to plus so on. It is mn vn. It is mn vn. Clear? So see, it is equation to find position of center of mass. Similarly, it is equation to find velocity of center of mass. Velocity of center of mass. Yes, if you write this equation, I can also write this equation as V center of mass is equal to, it is m1 v1 plus m2 v2 plus this plus so on mn vn, and divided by this capital M means total mass, means it is m1 plus m2 plus this plus mn. Okay, so yes, to solve some questions you have to remember this equation. To solve some questions you have to remember this equation. Okay, so yes, we have this equation. mv center of mass is equal to m1 v1 plus m2 v2 plus this plus so on. Okay, now we know that one quantity, linear momentum. What is linear momentum? Linear momentum is equal to mass into velocity. Linear momentum is equal to mass into velocity. So m1 v1, mass of first particle, velocity of first particle. m2 v2, mass of second particle, velocity of second particle. mn vn, mass of nth particle, velocity of nth particle. So yes, mass into velocity, it is called linear momentum. Mass into velocity, it is called linear momentum. So how to write this equation? Yes, I can write this equation as mv center of mass is equal to m1 v1 means it is p1, m2 v2 means it is p2 plus raised to plus so on, it is pn. Clear about this? Where what is p1? p1 is linear momentum of first particle. p2 is linear momentum of second particle. Dash dash dash. Clear about this? Okay. So yes, if system is made up of n particles, then linear momentum of first particle plus linear momentum of second particle plus linear momentum of third particle, etc., 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 it will give total linear momentum of system. So I can write this equation as mv center of mass is equal to p. mv center of mass is equal to p. Okay. So here I will write statement. Okay, total linear momentum of system total linear momentum of system is equal to product of mass of system and velocity of center of mass of system. Clear about this? Okay, so yes, this statement that you have to remember. Sometimes it is question that you have to prove. Okay, total linear momentum of system is equal to product of mass of system and velocity of center of mass of system. Prove this equation. So yes, you have to prove this. You have to prove this. Clear about this? Okay, so yes, it is one theory up to here. Now, next, yes, if we have this equation, that is mv center of mass is equal to, it is p1 plus p2 plus p3 so on, it is pn. Now, if we differentiate again, differentiate this equation with respect to time, differentiate this equation with respect to time. Differentiate this equation with respect to time. Then see what happens. It is m d upon dt of v center of mass is equal to, it is dp1 upon dt plus dp2 upon dt plus dp3 upon dt plus raised to plus so on. It is dpn Clear about this? So yes, and d upon dt of V center of mass is equal to dp1 upon dt plus dp2 upon dt plus dp3 upon dt plus so on. Now we know that rate of change of momentum is called force. Rate of change of momentum is called force. Rate of change of momentum is called force. So yes, here I can write this equation as m d upon dt of V center of mass is equal to dp1 upon dt, rate of change of momentum of first particle, means it is force acting on first particle, that is F1, plus dp2 upon dt, means it is rate of change of momentum for second particle, means it is what? F2. dp3 upon dt, means it is force acting on particle F3, plus S2 plus so on, it is F2, plus S2 plus so on, it is F2. Clear about this? So yes, how to obtain such equations. Now next F1 is force acting on first particle, F2 is force acting on second particle, F3 on third dash. So we can say F1 plus F2 plus F3 plus S2 plus so on, it is total force acting on system. Yes, it is total force acting on system. Yes or no? Yes, it is. And d upon dt of V center of mass. See, I can write this equation as m d upon dt V center of mass is equal to m d upon dt of V center of mass, means it is acceleration of center of mass, and it is equal to it is f, and is equal to it is f, or you can also write is equal to it is dp upon dt, that is total momentum and its differentiation with respect to time. Clear? So yes, m d upon dt of V center of mass is equal to, it is m a center of mass is equal to f is equal to dp upon dt, where f is resultant, external force on system, where F is resultant external force on system. Now why I have used term external? Why I have used term external? Because see, if we take system of particles, there are two types of forces, internal forces and external forces. Okay. If we take system of particles, there are two types of forces. For system of particles, there are two types of forces. First, internal, and second, external. For system of particles, there are two types of forces: internal forces and external forces. If I am taking one example of two particles, okay, suppose we have two particles, first and second. Okay, let on first particle external force acting is F1, and on two external force acting is on 2 is F2. So F1 and F2, they are external forces. But what is internal force? Internal force means interacting forces. And according to Newton's third law of motion, we know that force acting on one due to 2, if it is F1. So force acting on 2 due to 1, it is F2. Yes or no? Interacting forces obeys Newton's third law of motion. Okay. Internal forces according to Newton's third law of motion, F12 is equal to minus F12. So therefore resultant of internal forces is 0. Resultant of internal forces is 0. So in this equation star, F is only resultant of external force. Okay, here in equation here, in equation star, F is resultant of only external forces, Clear about this? So yes, this point you have to remember and see this equation, that is m E upon dt means center of mass is equal to m E, center of mass is equal to F is equal to dv upon dt. It is nothing but Newton's second law of motion. Equation star is called Newton's second law of motion. Equation star is Newton's second law of motion. It is Newton's second law of motion. Clear about this? So yes, it is Newton's second law of motion. And see, in this case here, this equation is Newton's second law of motion. But to prove or to obtain Newton's second law of motion, we have considered this phenomenon, that is Newton's third law of motion. See, for a particle, we can write Newton's second law of motion without help of Newton's third law of motion. But for system of particles, to obtain Newton's second law of motion, we have used Newton's third law of motion. So it is called interdependence of laws of motion. It is called interdependence of Newton's laws of motion. Clear about this? So yes, it is one whole theory, that is motion of center of mass and Newton's second law of motion. You have to remember three equations like this. R center of mass, m1r1 plus m2r2 plus s2 plus 1 mnrn upon m1 plus m2 plus s2 plus mn. Second of velocity, and third one of acceleration, Clear about this? So yes, it is one whole theory. What is interdependence of Newton's laws of motion? See, for a particle, Newton's second law of motion can be written without help of third law. Okay, but for system of particles, to write Newton's second law, third law of motion is used. Third law of motion is used. Means to derive one law, another law is used, and therefore it is called interdependence of Newton's laws of motion. Clear about this? So yes, it is one whole theory, that is Newton's second law of motion. You have to operate for system of particles. Clear about this? So yes, for today, this is it.